it's puzzling to me that this one is also acting up.
Yeah. Well, it was puzzling when this one stopped for no reason to begin with.
Yeah.
We're gonna try to do a full test this time. Initiating. Clear prop. That's not started. All right. What's that?
Rear assembly?
Yep. Shit. Rear assembly.
ESC?
Lost a cap.
Oh, a whole MOSFET popped up.
Now that is surprising. If we, that 200, if that gets up to 200, you yell out.
Yeah, I'll call out.
All right, here goes. All right, it just said broken.
Nice.
50%.
That was 50?
Complete.
That's 50%. The only thing that was the only thing that was sort of concerning for me is the EDS were
Yeah, I saw that. I saw that top one.
Yeah.
Only on this side there.
Yeah.
Yeah, so the ESC is on the back. We swapped out for larger ones. And you're powered off?
Yeah.
So we put larger ones on. Oh, that's kind of toasty.
What is?
Those capacitors.
Oh.
Huh. The motor.
Yeah.
Well then, the bottom one's not, but this top one, I can barely touch
Hot? Hot?
it.
Not just warm?
Yeah.
Oh my.
Yeah.
Wow. Yeah. It's. Well. You gotta smell too. That was 50?
Yeah.
Well, 75%? Up to 75 and then I'll
Yeah.
just bring it down. We won't hold.
Okay. I mean, really.
Maybe I'll hold for 10 seconds.
Okay, here we go. Why are we rising?
The left side EDF was out. Middle one. It wasn't.
Really?
Yeah.
So, we weren't even at full on that last one, and we were heating up the bus itself. Dang it. Well, yeah, a lot of drilling holes and recreating a bus.
Great.
We're flicking right now. How about that second one?
The second one is flickering?
The second
beeping?
one is...
Is it solid? Solid LED would be no bueno.
Yes. Clear prop. Not good.
Damn.
I'm not a fan.
it's puzzling to me that this one is also
Yeah,
acting up.
yeah. Well, it was puzzling when this one stopped for no reason to begin with.
Yeah.
We knew this side was working.
Mm-hmm.
Yeah. All right. Hit the button. Clear prop. Yep. Yep. ESCs again.
ESCs, yeah.
That's not great. We will bail on this test,
Yeah, we're gonna have to.
and we will take those out, put them in the lab, and we'll take a look at them deeper. We're not changing anything. Nothing's changed.
Yeah.
All right, 100% test. New configuration. I got nothing else to say. 2 minutes is the goal.
Yep. Cool, man.
All right,
Let's do it.
clear prop.
Alex,
Go. All right.
14.3.
better. Not quite 2 minutes, but
How'd that go?
the first one.
About 2 minutes? The 2
No.
No. About 1:20 almost. And we hit, what, 250? A little bit higher than 250. I shut it down at 250, but it climbed up to 267, looks like.
Yep.
It should be enough.
Yeah? You got a minute.
It should be enough.
All right.
Full throttle.
I'll take a minute at this point.
I'm pretty confident in the bus being consistent now.
Never been to a
Um,
chiropractor.
Let's run it. Let's just stall it at 125 and pass.
That sounds good to me.
Cool. Good job, guys.
Hey, we could put it in the report too, so,
Yeah.
yes.
Good work.
Okay.
Yeah. What am I doing here?
If I stay, we'll run this at 5. That'd be good.
Okay. At the beginning, it was overheating in about 30 seconds. The power bus, way undersized, aluminum, save weight. It's all about weight for aircraft. And no matter what you propose, the aero guys want less weight. Yeah, that's right. I'm blaming you, Aldous. But anyway, can we cool it enough to make it work? In this case, no. So what did we do? Go back to the drawing board, put additional MOSFETs on there, put a physical switch, one of them was, to bypass the MOSFETs. So once it's powered on, you throw that switch and it locks it in and bypasses the MOSFETs. Now the MOSFETs aren't heating up. Well, when that happened, what we found was the bus itself, being undersized, was heating up just with how much current was going through it. So we upped it like crazy. And even when we upped it like crazy, it's still half of what it should have been. So half the size is what it should have been for continuous use for the current that we were pulling. We had slightly over a minute. Worst case scenario, with the configuration where we have 2 batteries on 1 MOSFET and then Total, there was only 4 MOSFETs breaking all of this. Mathematically, they can handle it. Physically, we can't cool it fast enough with the setup that we have, with the little cooling fans and everything. We would need to have something much bigger in order to dissipate that heat. There's other options to be done. We could use relays and things like that. But again, the size that we would need, much heavier than the MOSFETs that we were using. So it always goes back to what can we compromise in order to make it just good enough to work.
Yeah.
Now, when we go into production, we'll make it so it'll never fall out of the sky because of that. We won't sacrifice any safety, of course. And this, we only need it to fly a certain amount to prove out the system. Once the system's proven out, now we can start to make everything else as light as possible and yet as robust as possible, and really do the engineering to find that blend. That's kind of the conclusion of where we landed on that. I mean, yeah, lots of things learned of what we can compromise, what we can't compromise, but it's part of engineering. You build it, test it, see if it passes, and then refine it if you need to.